Okay, we are looking at more volume today. This time it's pyramids and cones. So the three-dimensional, what it takes to fill them up. And it's interesting with pyramids and cones how it changes it. The rectangular pyramid is 1/3 of a rectangular prism with the same base and height. So we did the prisms yesterday, right? The rectangular prism. And if you make that instead into a pyramid, so it comes up to a vertex or a point, it is exactly 1/3 of that prism that we looked at yesterday. So here they have kind of a rectangular prism that they're showing us. And then these are the three pieces it can be split into. They're all exactly the same volume. And it's of that's a visual. There's always a little video here that should be helpful if you need to see. I tried to pick videos where things move and you can actually watch it shift around and become the thing you're looking at. This formula, the volume of a pyramid is 1/3 the area of the base times the height. So if you look at just this piece, that's what we did in the last section, right? For the prisms, the area of the base times the height. And now we're going to split it into 3 parts and take one of those for the area of the pyramid. So base is, again, that thing at the bottom, or it's not necessarily at the bottom, but that shape that is flat, and then everything comes to a point off of it. Off of that is the vertex. The height is now, this is a little bit different. It's not the slant height like when we did surface area. This is the height of the pyramid. So it starts in the center or the bottom of the pyramid and shows you how tall it is to the vertex. How high is it from the vertex? So really you would start at the vertex, draw down, and have a line that is perpendicular to the base. Okay, so not slant height, not like the surface area. Let's try one and see how this goes. 1/3 the area of the base times the height. But just like when we did yesterday, we had to figure out what is the area of the base. So I'm going to put that here. Capital B, the area of this base. This base is a square. So to find the area of a square, you would do side times side or base times height. 8 times 8. And that is 64 feet squared for the area of our base. Now we're going to plug that in to the volume formula, 64, and we need to know the height. Remember, that's perpendicular off the bottom. How tall exactly, or what's the distance from the vertex to the base with the perpendicular line? So 10. Let's multiply those. And I'm going to do 64 times 10 divided by 3, 213 we're rounding. So 213.3 feet cubed. This is a volume. Okay, so really what's changed from yesterday is we're dividing it by 3. Let's try another one together. This guy, now notice his height is not necessarily like right in the center of the base, but it is perpendicular to the base. So that is the correct piece that we need. The area of the base times the height. Put a little squiggle here. What is the area of our base? Here's the base. It's this big square at the bottom. And it's square, right? So base times height, 15 times 15, which is 225 inches squared. Okay, we're ready to plug that back in. We know this is 225. Now, what's the height of the pyramid? They gave us that measurement, 16, and I didn't put my 1/3. Whew. That was going to be wrong. 225 times 16, and I only need 1/3 of that. So 1,200 inches, and it's cubed. It's a volume. Okay. All right. I'm going to have you guys pause your video and try these 2 at the bottom. You've got 2 pyramids One has a square for a base, or no, it has a rectangular base, and then the other one actually has a triangular base. So be careful. Make sure you're thinking about that. How do you find the area of a triangle? Okay. All right, let's try this. 1/3 the base times the height. You need to know what the area of the base is. It's just a rectangle, so 12 times 8. And that is 96 feet squared for that square at the bottom. Let's plug him in. 1/3, 96. And now I need to know the height of this pyramid, and that is a 10, right? He's here in the middle. So let's put that together. 96 times 10. And I only need 1/3 of it, 320 feet cubed. Got that? All right, now this one was a little different. We didn't do one with a triangular base yet, have we? Let's do still 1/3 the area of the base times the height. To find the area of a triangle is 1/2 base times height of the triangle, not big base, but the little base. So if I'm looking at I'm just gonna shade in my triangle here. This guy right here is the base of the whole pyramid. And the base of this triangle is 10. And the height of that triangle is 6. Okay? 10 times 6 is 60. Half of that is 30. So our base is 30 inches squared. And we're ready to take that number and plug it in. The area of the base is 30. Now what's the height of the pyramid? We need a perpendicular line that goes from the vertex to the base, and that is 8 inches. 30 times 8, 1/3 of that is 80 inches cubed. Okay, that's volume of a pyramid, 1/3 of the volume if it were a rectangular or just a regular prism. Triangular it could be. Let's turn this over and look at cones. Think they might be similar? Okay, remember we found out cylinders were really similar to prisms. Just like a pyramid, a cone is 1/3 of a cylinder, as long as it has the same base and the same height. Remember that the base is a circle. That's really what's different about this and a pyramid. And the area, I'm going to write that one more time, pi r squared. So here we go. Here's a cone. The volume is 1/3 the base times the height. Same thing as the front, right? Or if it helps you, we can plug it in. The area of the base is pi r squared times the height. Okay, so find the area of the base, multiply it by the height, and divide it into 1/3. Okay, and they're showing us that the base is the circle, the radius is from the center to the edge of the circle, and the height again runs from the vertex down and hits the base in that perpendicular line. Okay, let's try some. 1/3 area of the base times the height, but what is the area of the base? We'll have to find it. Pi r squared, pi, and our radius from the center to the edge is 6 squared. So we'll do 36 times pi, 113.1 centimeters squared. Okay, we've got our base. Let's put it in here to the volume, 113.1. What's the height of our cone? Uh-oh, they didn't give us, that would be the distance right here. And instead, they gave us the slant height, which would be great if we were doing surface area, but we're not. So think about that as a triangle. It sure looks like a triangle, right? I'm going to pull it out. Boom, boom. We know this is 10, this is 6, but the side we want, I'm going to put a B there, is that height for the cone. So we can use Pythagorean yet again, right? A squared plus B squared equals C squared. Make sure you get that hypotenuse on the other side of the equal sign. That is 6 squared is 36. And we'll subtract 36 from each side and we get 64. Oh, good. At least it's a whole number. You guys know what the square root of 64 is. Yeah, okay, 8 centimeters. Okay, that was a little more work than I was expecting, but we can do it. We're good at this. So the height of this cone is 8 centimeters. Be careful not to use the slant height if that's what they give you. We don't want that. 113.1 times 8. And I only need a third of that, 301.6 centimeters cubed. Okay, let's do one more together. It's 1/3 base of the area times the height. And this base is a circle, since it's a cone, pi r squared. They didn't give us the radius though. They gave us the diameter. How do you find the radius? Cut that in half, good. So 36 times pi, 113.1 centimeters squared. Hey, that's the same as the last one we did. Okay, so same base on these two. Let's put him in here. 1/3, 113.1. Now the height, they didn't draw it the way that we're used to, but this is not a slant height. That is the height from the base to the vertex. So that is actually the number that we need, even though it didn't quite look like the way that we're used to seeing it. Okay, 1/3, so 113.1 times 30. And let's get a third of that. You should get 1,131 inches cubed. Volume of that cone. All right, you guys have 2 to try. Pause your video. Take a second, try those, and then come back. All right, let's look. This guy is upside down. Wonder if that will make it any harder to figure this out. That's our formula to find the area of the base, pi r squared. So 8 squared, 64 pi, 201.1. 201.1 feet squared. We're ready to plug that in then. 201.1. Now, the height, did they give us the height of this guy? They did, 10. It's exactly what we needed. Let's do that. 201.1 times 10 divided into thirds. Did you get 670.3 feet cubed? If so, yay, you did it. Let's check your last one too then. 1/3 base times height. What's the area of the base? Pi r squared. And our radius is not 5. It's half of that, 2.5 squared. 2.5 squared times pi is 19.6 centimeters squared. Okay, we're ready to put that in. 1/3, 19.6. And then, hey, they gave us the height again. Perfect. 19.6 times 12 divided by 3, 78.4 centimeters cubed. Done. That's what you got. All right. Awesome. You guys are ready. You've got an assignment to do some practice problems. Good luck.